Did you know as a chemist, if you can code, you're instantly more valuable to your company? Your starting salary can easily be $20,000 to $30,000 more than someone who cannot code. Whether you're a freshman in college or a graduate student or our very average Joe here, if you can code while no one else around you can, your value to a recruiter or your current employer will instantly be better than Joe's, for example. Take a look at this comparison. As a chemist, you can make a starting salary of $55,000 to $86,000 per year in the United States, while as a computational chemist, your starting salary can be between $69,000 to $124,000 per year, which is significantly better. Just take a look around you, the people you work with, your friends, your colleagues, your neighbors, people who have graduated before you, and those annoying kids in school, and just think for a second, how many of them can code? There's two possible answers. Either not many of them can code, or all of them but you can code. Whatever the answer is, here's how you can add value if you learn to code. For this, let's first ask Joe if he can code in Python. No, Joe can't code, which is great for you. So think about this. The biggest challenge that chemical companies can face is not the supply chain crisis or marketing or balancing their budget. Yes, some of these are challenging, but the biggest challenge is idea generation and problem-solving abilities. Innovation is directly responsible for a company's growth. And this is where the power of computation can come into play. And if you specifically look at programming, it has the capability to solve complex problems faster than ever before. The basic idea is if your code can automatically perform a tedious task, like say making a graph or a chart in a matter of seconds, or if you have some kind of measurements coming in that needs to be processed repeatedly, mind you, this could take hours in Excel depending on the complexity. But now if you can code, this can be done in a matter of seconds. You will be saving hours of your time and effort that you can use to think of more ideas, or you could use it to read more and learn more, which eventually helps you solve complex problems in the long run. This right here is what many big companies want. And if you think of other reasons, be sure to let us know in the comments below and I will address them at a much deeper level in my next video. Just ask Joe. He just got laid off and he's begging me to talk about it. But here's the real kicker. There is a huge vacuum that still exists because people who are really good at coding, like the computer science guys, don't know much of chemistry, while folks in chemistry are not as good as them when it comes to programming. So if you are somewhere in the middle, if you can position yourself in the middle where you can code and also do chemistry, you are bringing insanely good value to your employers or your future employers. And this is your value proposition. It's more likely that a chemist would be open to learning how to code versus a computer scientist to learn chemistry. Just think about that for a second. The reason I say this is because there is a huge learning curve for a computer scientist proficient in Python to learn chemistry. Whereas for chemists or physicists or other majors like you and me, learning to code is far more easier compared to learning our majors of studies like chemistry, physics, or whatever, biology, anything. Which is also one of the reasons why Python is one of the most widely used programming languages out there. So whether you're a freshman in college, a senior, or a graduate student, or an employee at a company, start to think from this perspective. By the way, Joe's going through some real life changes and you can help him out by hitting that like button. Trust me, it's for Joe. So let's say you put in the time and effort to learn how to code in Python and you want to know how you can apply this newfound skill that you have in the field of chemistry. Here's some examples. First, regardless of whether you're an experimental chemist or a computational chemist, you will be dealing with a lot of data. Something you might want to plot and make it look beautiful so it can go into your presentations and publications. Well, if you can code in Python, you can make all these amazing looking charts and plots with just a click of a button using packages like Seaborn and Matplotlib. They save you time and you don't have to worry about missing out on labeling the titles or providing legends and all those tiny little details that you most often would miss if you try to use something like Excel to make these plots. This will help you analyze your data and make inferences much more easily. As an experimentalist, you could even automate some of your experiments using robotics. And no, this is not a fairy tale. There are many research groups working on automating experiments, and this is becoming more of a reality. So why not catch on and get your hands into it? So when automation or robotics hit you, you're better prepared. And if you're a little bit more into computational chemistry like I am, you can use your coding to automate some of the most tedious and repetitive and boring tasks, like setting up a DFT calculation, for example. And another place where you can apply your coding skills is in molecular modeling, and pharmaceutical companies would die to have you on board because you're good at both programming and also you're synthesizing proteins or characterizing these molecules. You're gonna bring a lot more value to their company. And this is just a few examples. With AI and machine learning, in recent years, the number of job opportunities and research opportunities are increasing day by day. Almost every employer wants a computational chemist to have a project or two in their portfolio that they can demonstrate their skills. And this is very important to them. And by the way, if you're already in this field or if you're applying to get into this field in a college or somewhere, here's some keywords that you need to keep an eye on so that when it comes to applying for jobs, you know what you're looking for. Number one is drug discovery. This is a very broad field responsible for, you guessed it, discovering new drugs that can cure diseases and illnesses like diabetes, cancer, and other viral infections. There are a number of databases updated regularly to train machine learning models that can predict various properties of small molecules suitable as drug candidates. And then there's material science to design materials for applications like solar cells, electrodes for batteries, catalysts to convert carbon dioxide, etc. Again, just like drug discovery, there are many databases that can be used to train deep learning models like surrogate models, machine learning potentials, etc., all of which require you to be proficient in Python. For example, if you look at the number of papers published and cited in this area using ML or AI, you can see how the number of people working in this field is growing, and there is a solid reason for this. By the way, the flat line that you see for these numbers in recent years is because these numbers haven't been updated yet, and once they're updated, I'm sure that it will go up. Which is why I've asked Joe here to help us out to investigate why so many people are interested in computational chemistry. Where's Joe? Hope he didn't fall up the stairs again. A lot of this work involves learning and implementing complex algorithms, and the first steps you can take is learning how to code in Python, which is why I have this video here for you to get started. And if you're still here, please like this video so it can help out people like Joe to learn more about this channel, and do subscribe so that we can grow as a community together. Thank you for watching. I'll see you in the next one.